According to the National Electrical Code, specifically NEC Section 320.80a, when any portion of a Type AC cable is installed within thermal insulation, the ampacity of the entire circuit run must be adjusted to align with the 60 degrees Celsius temperature rating. The reasoning behind this code requirement lies in the potential for thermal insulation to trap heat around the electrical cable. This heat buildup can cause the cable to overheat, which in turn elevates the risk of electrical fires and premature degradation of the cable's insulation. Consequently, even if only a small segment of the cable is surrounded by insulation, the code mandates that the entire circuit be treated as if it were operating under the 60 degrees Celsius ampacity limitations. In the scenario where a 75-foot branch circuit utilizes 10-2 AC cable to power an air conditioning unit with a minimum circuit ampacity requirement of 31 amps, and a 5-foot section of that cable passes through a wall containing fiberglass insulation, the entire 75-foot circuit must adhere to the 60 degrees Celsius ampacity rating. For 10-2 AC cable, the 60 degrees Celsius ampacity is typically 25 amps. This presents a problem, as the air conditioning unit requires 31 amps, exceeding the allowable ampacity of the circuit when derated for the insulation. The exception found in NEC Section 310.15 addresses situations where cables pass through or are installed in locations considered hazardous or classified. This exception allows for a limited section of the cable to be evaluated based on its specific conditions, rather than applying the temperature limitations of the surrounding environment to the entire circuit. However, this exception is not applicable to a standard wall filled with fiberglass insulation. The NEC defines hazardous locations as areas where fire or explosion hazards may exist due to flammable gases, vapors, dust, or fibers. A typical wall cavity with fiberglass insulation does not meet the criteria for a hazardous location. Therefore, the exception cannot be invoked to justify using the 75 degrees Celsius or 90 degrees Celsius ampacity for the portion of the cable outside the insulated wall. To reiterate, because any portion of the AC cable is installed in thermal insulation, the entire 75-foot circuit must be rated as if it were operating at 60 degrees Celsius. This is irrespective of the fact that only 5 feet of the cable is actually in the insulation. The implication of this rule is significant. It can necessitate the use of larger gauge conductors to meet the ampacity requirements of the connected equipment, particularly in situations where the equipment's minimum circuit ampacity is close to or exceeds the 60 degrees Celsius rating of the initially selected cable. In order to comply with the NEC and ensure a safe and reliable electrical installation, it is essential to carefully consider the presence of thermal insulation and its impact on the ampacity of AC cables. Ignoring this requirement can lead to overheating, potential fire hazards, and violations of electrical codes. When dealing with AC cable installations in thermally insulated environments, it is prudent to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable NEC regulations. The determination of whether a location qualifies as hazardous is based on specific criteria outlined in the NEC, primarily Article 500 and subsequent articles addressing specific types of hazardous locations. These articles define the characteristics of hazardous locations, including the types of flammable or combustible substances present, their concentrations, and the likelihood of their presence. A key factor in determining whether a location is hazardous is the presence of flammable gases, vapors, dust, or fibers in sufficient quantities to create a risk of fire or explosion. The NEC classifies hazardous locations into different classes and divisions based on the nature of the hazard and the likelihood of its presence. Class A locations involve flammable gases or vapors, Class Roman II locations involve combustible dust, and Class Roman III locations involve ignitable fibers or flames. Within each class, divisions further categorize the risk based on the probability of the hazardous substance being present under normal or abnormal operating conditions. To properly classify a location as hazardous, a thorough evaluation of the environment is necessary. This evaluation should consider the types and quantities of hazardous substances present, the ventilation characteristics of the space, and the potential for accidental releases or spills. In some cases, specialized testing or analysis may be required to determine the concentration of hazardous substances and assess the overall risk. It is important to note that the presence of thermal insulation alone does not automatically qualify a location as hazardous. Thermal insulation is primarily used to reduce heat transfer and improve energy efficiency. While it can contribute to heat built up around electrical conductors, it does not inherently create a risk of fire or explosion unless flammable materials are also present. Therefore, a wall cavity filled with fiberglass insulation without the presence of flammable gases, vapors, dust, or fibers would not be considered a hazardous location under the NEC. In such cases, the ampacity dating requirements of NEC 320.80 would still apply, but the exception for hazardous locations would not be applicable. To provide a more detailed explanation of the NEC requirements for AC cable ampacity in thermal insulation, let's delve into the specific sections of the code and explore the underlying principles. NEC section 320.80 states that if any portion of a type AC cable is installed in thermal insulation, the ampacity of the entire circuit must be adjusted to the 60 degrees Celsius rating. This requirement is intended to protect the cable from overheating due to the reduced heat dissipation in the presence of insulation. Thermal insulation acts as a barrier to heat flow, preventing the cable from effectively dissipating heat into the surrounding environment. This can lead to a significant increase in the cable's operating temperature, which can degrade the insulation and potentially cause a fire. The 60 degrees Celsius ampacity rating is a conservative value that ensures the cable will not exceed its maximum operating temperature under normal conditions, even when surrounded by thermal insulation. It is important to note that the NEC does not define thermal insulation specifically, but it generally refers to materials that have a high thermal resistance and are used to reduce heat transfer. Common examples of thermal insulation include fiberglass, mineral wool, cellulose, and foam insulation. The ampacity of a cable is the maximum amount of current it can safely carry without exceeding its temperature rating. The ampacity of a cable is determined by several factors, including the conductor size, insulation type, and ambient temperature. The NEC provides ampacity tables for various types of cables and conductors based on different temperature ratings and installation conditions. These tables are essential for selecting the appropriate cable size for a given application. In the case of AC cable installed in thermal insulation, a 60 degrees Celsius ampacity rating must be used, regardless of the cable's insulation type or the ambient temperature. This is because the insulation effectively creates a localized hotspot around the cable, which can significantly increase its operating temperature. The exception in NEC 310.15 ATWA allows for a limited section of cable to be evaluated based on its specific conditions, rather than applying the temperature limitations of the surrounding environment to the entire circuit. However, this exception is only applicable to hazardous locations as defined in the NEC. Hazardous locations are areas where fire or explosion hazards may exist due to flammable gases, vapors, dust, or fibers. These locations require special wiring methods and equipment to minimize the risk of ignition. A typical wall cavity with fiberglass insulation does not meet the criteria for a hazardous location. Therefore, the exception in NEC 310.15 ATWA cannot be invoked to justify using the 75 degrees Celsius or 90 degrees Celsius ampacity for the portion of the cable outside the insulated wall. To further illustrate the application of these rules, consider the following example. A 100-foot branch circuit is installed using 12 -2 AC cable to supply power to a lighting fixture. The circuit passes through a 10-foot section of wall that is filled with fiberglass insulation. The lighting fixture requires a minimum circuit ampacity of 15 amps. According to NEC 320.80A, the entire 100-foot circuit must be rated at the 60 degrees Celsius ampacity because a portion of the AC cable is installed in thermal insulation. For 12 -2 AC cable, the 60 degrees Celsius ampacity is typically 20 amps. Since the lighting fixture only requires 15 amps, the 12 -2 AC cable is sufficient for the application. However, if a lighting fixture required 25 amps, the 12 -2 AC cable would not be sufficient, and a larger gauge cable would be required to meet the ampacity requirements. In this case, a 10-2 AC cable could be used, which has a 60 degrees Celsius ampacity of 25 amps. Alternatively, the circuit could be rerouted to avoid the thermal insulation altogether. This would allow the use of the 75 degrees Celsius or 90 degrees Celsius ampacity for the entire circuit, which would likely allow the use of a smaller gauge cable. In summary, the NEC requires that the entire circuit be rated at the 60 degrees Celsius ampacity when any portion of an AC cable is installed in thermal insulation. This requirement is intended to protect the cable from overheating and prevent potential fire hazards. The exception in NEC 310.15 adhere is not applicable to standard wall cavities filled with fiberglass insulation. Therefore, it is essential to carefully consider the presence of thermal insulation when selecting the appropriate cable size for an electrical installation. The minimum wire size for a given ampacity is determined by the National Electrical Code, specifically Table 310.16 in the 2020 NEC edition, which is a widely adopted standard. This table provides ampacity ratings for various conductor types and sizes based on their insulation temperature rating. However, it's important to remember that the allowable ampacity listed in Table 310.16 is subject to adjustments based on several factors. These factors include the ambient temperature, the number of current-carrying conductors in a raceway or cable, and whether the conductors are installed in thermal insulation. To determine the minimum wire size, you must first determine the ampacity required for the circuit. This is typically based on the load that the circuit will serve, such as lighting, appliances, or equipment. The NEC provides guidelines for calculating the ampacity of various types of loads. Once the required ampacity is determined, you can consult Table 310.16 to find the minimum wire size that has an ampacity rating equal to or greater than the required ampacity. However, you must also consider any applicable adjustment factors. For example, if the ambient temperature is higher than 30 degrees Celsius, you must apply a temperature correction factor to the allowable ampacity. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, you must apply a derating factor to the allowable ampacity. The temperature ratings of conductors refer to the maximum temperature that the conductor's insulation can withstand without degradation. Common temperature ratings include 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The higher the temperature rating, the more current the conductor can safely carry. However, it's important to note that the temperature rating of the conductor is not the only factor that determines the allowable ampacity. The NEC also specifies limitations on the termination temperature of equipment. This means that the equipment to which the conductor is connected must be rated for a temperature equal to or greater than the conductor's temperature rating. For example, if you are using a 90 degrees Celsius conductor, the equipment to which it is connected must also be rated for 90 degrees Celsius. If the equipment is only rated for 75 degrees Celsius, you must use the 75 degrees Celsius ampacity rating for the conductor. In practice, it is always best to consult the latest edition of the NEC and consult with a qualified electrician or electrical engineer to ensure that you are selecting the correct wire size for your application. These professionals can help you to accurately calculate the required ampacity, apply any necessary adjustment factors, and ensure that your electrical installation complies with all applicable codes and standards. Remember that electrical safety is paramount, and using the correct wire size is essential for preventing overheating, fires, and other electrical hazards. The NEC provides tables for ampacity derating based on the number of current-carrying conductors in a raceway or cable. These tables are found in NEC Table 310.15 current in the 2020 edition, and they provide adjustment factors that must be applied to the allowable ampacity of conductors when there are more than 3 current-carrying conductors in a raceway or cable. The ampacity derating factors are based on the principle that the more conductors there are in a raceway or cable, the more heat is generated, and the less effectively the heat can be dissipated. This can lead to an increase in the conductor's temperature, which can degrade the insulation and potentially cause a fire. The derating factors in NEC Table 310.15 vary depending on the number of current-carrying conductors. For example, if there are 4 to 6 current-carrying conductors in a raceway or cable, the allowable ampacity must be derated to 80% of its value as listed in NEC Table 310.16. If there are 7 to 9 current-carrying conductors, the allowable ampacity must be derated to 70% of its value. It is important to note that the derating factors in NEC Table 310.15 only apply to current-carrying conductors. Grounding conductors and equipment grounding conductors are not considered current-carrying conductors for the purpose of ampacity derating. Also, the NEC provides exceptions to the derating requirements in certain situations. For example, if the conductors are installed in a raceway that is exposed to free air, the derating factors may not apply. The ambient temperature also affects the ampacity of conductors. The NEC provides temperature correction factors that must be applied to the allowable ampacity of conductors when the ambient temperature is higher or lower than 30 degrees Celsius. These temperature correction factors are found in NEC Table 310.16. The temperature correction factors are based on the principle that the higher the ambient temperature, the less effectively the heat can be dissipated from the conductor. This can lead to an increase in the conductor's temperature, which can degrade the insulation and potentially cause a fire. The temperature correction factors in NEC Table 310.16 vary depending on the insulation type of the conductor. For example, for conductors with a 90 degrees Celsius insulation rating, the temperature correction factor is 0.88 when the ambient temperature is 40 degrees Celsius. This means that the allowable ampacity of the conductor must be reduced to 88% of its value as listed in NEC Table 310.16. In summary, the NEC provides detailed guidelines for ampacity derating based on the number of current-carrying conductors and the ambient temperature. These guidelines are essential for ensuring that conductors are not overloaded and that electrical installations are safe.